Solving rational equations. A rational equation in one variable is an equation in one variable in which both sides can be written as rational expressions. With rational equations, it is possible to take the usual steps for solving equations, yet arrive at x values that are excluded values for one or more of the fractions in the equation. These values of x are not solutions. We call such values extraneous solutions. Since multiplying both sides of a rational equation by the LCD and then simplifying both sides may introduce extraneous solutions, we must always check that any proposed solution is not an excluded value. Solving a rational equation in one variable. To solve a rational equation in one variable, 1. Factor the denominator or denominators, if possible. 2. Identify any excluded values. 3. Find the LCD of all the fractions. 4. Multiply both sides of the equation by the LCD, which gives a simpler equation to solve. 5. Solve the simpler equation. 6. Discard any proposed solutions that are excluded values. In this example, solve. Any solution is a real number. 2 divided by x minus 3 equals 9 over x plus 4. Because we have fractions, we need to check to see if we have an extraneous solution. Since both of my denominators are x, I set x equal to 0. So my extraneous solution is 0. Next, we want to find the least common multiple for these terms. My denominators are x, 1, x, and 1. I can change my whole numbers to fractions by writing them over 1. So that means that my denominators are x, 1, x, and 1. The least common multiple of x and 1 is x. So we want to multiply our equation by x. My first step is to multiply my entire equation by x. As long as I'm multiplying every term by the same thing, I still have an equality. So I start with 2 over x times x over 1 minus 3 times x equals 9 over x times x over 1 plus 4 times x. 2 divided by x times x over 1, the x's cancel, and 2 times 1 is just 2, minus 3 times x is 3x, equals 9 over x times x over 1, the x's cancel, so I have 9, plus 4 times x, which is 4x. Now I have an equation without fractions. 2 minus 3x equals 9 plus 4x. Start by getting the x's on the same side. I can add 3x to both sides, which means 2 equals 9 plus 4x plus 3x is 7x. My next step is to subtract both sides by 9. 2 minus 9 is negative 7, which equals 7x. Then divide both sides by 7. Negative 7 divided by 7 is negative 1, and that equals 7x divided by 7, which is x. So I have x equals negative 1 as my final answer. So I want to check to make sure negative 1 is not my extraneous solution. Since the extraneous solution is 0, then my final answer is x equals negative 1. In this example, solve. Any solution is a real number. 3x plus 2 divided by x minus 3 equals x plus 8 divided by x minus 3. First, we want to find our extraneous solution. Since both our denominators are the same, all we have to do is take x minus 3 and set it equal to 0, which means x equals 3. So our extraneous solution is x equals 3. Since both our denominators are the same, our least common multiple is x minus 3. 3x plus 2 divided by x minus 3 times x minus 3 over 1 equals x plus 8 divided by x minus 3 times x minus 3 over 1. X minus 3's cancel, leaving me on the left with 3x plus 2 equals, on the right, the x minus 3's cancel, so that leaves me with x plus 8. Subtracting x from both sides, 3x minus x is 2x, plus 2 equals 8. Then subtracting 2 from both sides, 2x equals 8 minus 2, which is 6. Dividing both sides by 2, x equals 3. My solution is x equals 3. But since that's my extraneous solution, my answer is no solution. In this example, solve. Any solution is a real number. 3 divided by x minus 4 minus x divided by x plus 2 equals 2x plus 10 divided by x squared minus 2x minus 8. My first step is to factor x squared minus 2x minus 8. I need two numbers that multiply to be a negative 8 but add to be a negative 2, which is x minus 4 and x plus 2. So that means that my least common multiple is x minus 4, x plus 2. I have an x minus 4 already and an x plus 2 already. So now I can find my extraneous solutions. I want to set x minus 4 equal to 0, which is x equals 4. I also want to set x plus 2 equal to 0, and I get x equals negative 2. My extraneous solutions are 4 and negative 2. Now I'm ready to find x. Our next step is to eliminate our denominator. So we multiply the equation by the LCD, which means we have 3 divided by x minus 4 times x minus 4 times x plus 2 divided by 1 minus x over x plus 2 times x minus 4 times x plus 2 all over 1 equals 2x plus 10 divided by x minus 4 x plus 2 times x minus 4 times x plus 2 all over 1. Going back to our first term, x minus 4 cancels with x minus 4, which leaves me with 3 times x plus 2 minus x plus 2 cancels with x plus 2, so that leaves me with x times x minus 4 equals x minus 4 cancels with x minus 4, x plus 2 cancels with x plus 2, so that leaves me with 2x plus 10 times 1. I'm ready to use my distributive property. 3 times x is 3x, plus 3 times 2 is 6, minus x times x is minus x squared, minus x times minus 4 is plus 4x, equals 2x times 1 is 2x, plus 10 times 1 is 10. Combining like terms, I have negative x squared plus 7x plus 6 equal to 2x plus 10. Because of my x squared, I need to set it equal to 0. Since it's a negative x squared, I want to get all the terms on the right side of the equals, so I have a positive leading coefficient. 0 equals, adding x squared to both sides, I have a positive x squared. Subtracting 7x from both sides, 2x minus 7x is minus 5x. Subtracting 6 from both sides, 10 minus 6 is a positive 4. And now I'm ready to factor. I need two numbers that multiply to be a positive 4 but add to be a negative 5. X minus 4, x minus 1, and that equals 0. Setting each of them equal to 0, x minus 4 equals 0, which means x equals a positive 4, or x minus 1 equals 0, which means x equals a positive 1. Checking my values for x against my extraneous solutions. One of my extraneous solutions is 4, so that means x equals 4 is not a part of my solution set, just x equals 1. In this example, solve any solution is a real number. I have 3 over x plus 1 plus 2/5 equals 1. Looking at my least common multiple, I have x plus 1 and I have 5. So 5 times x plus 1 will be my least common multiple. Because that's in the denominator, I need to check to see if I have an extraneous solution. Since x plus 1 is the only part of this with a variable, if I set x plus 1 equal to 0, that means x would equal negative 1. So my extraneous solution is negative 1. My next step is to multiply my equation by my least common multiple of 5 times x plus 1. 3 over x plus 1 times 5 times x plus 1 all over 1 plus 2/5 times 5 times x plus 1 all over 1 equals 1 times 5 times x plus 1. Now I'm ready to cancel what I can. The x plus 1's cancel, so I have 3 times 5, which is 15, plus I have my 5's canceling, so I have 2 times x plus 1, which gives me 2x plus 2 equals 1 times 5 is 5, and 5 times x plus 1 gives me 5x plus 5. Adding my like terms, 2x plus 17 equals 5x plus 5. So I need to solve for x, first by subtracting 2x from both sides. 17 equals 5x minus 2x is 3x, and bring down the plus 5. Then subtract 5 from both sides. 17 minus 5 is 12, equals 3x. Divide both sides by 3. 12 divided by 3 is 4, and 3x divided by 3 is x. I need to check to make sure my value for x is not an extraneous solution. Since it is not, my answer is x equals 4. In this example, solve. Any solution is a real number. X squared minus 23 divided by 2x squared minus 5x minus 3 plus 2 over x minus 3 equals negative 1 over 2x plus 1. First, we want to find our least common multiple, and that will help us find our extraneous solutions. I have 2x squared minus 5x minus 3. That means I need two factors of 2 times negative 3 is negative 6 that add to be negative 5. Divide each of those by a. Negative 6 times a positive 1 gives me a negative 6. Negative 6 plus 1 gives me a negative 5. Negative 6 over 2 reduces to negative 3 over 1. So my parentheses are x minus 3 times 2x plus 1. Now we want to find the LCM, so I write down what's in my first denominator, which is x minus 3 times 2x plus 1. Then I check my next denominator. I already have an x minus 3 in my LCM, so I don't need to write it again. Check my third denominator. I have a 2x plus 1, so I don't need to write it again. Using my LCM, I want to try to find my extraneous solutions. X minus 3 equals 0 gives me x equals 3. 2x plus 1 equals 0 gives me 2x equals negative 1, or x equals negative 1/2. My extraneous solutions are 3 and negative 1/2. So now we're ready to multiply our equation by our least common multiple so that we can cancel our denominators. So I start with x squared minus 23 divided by 2x plus 1 times x minus 3 times 2x plus 1 times x minus 3 all over 1 plus 2 over x minus 3 times 2x plus 1 times x minus 3 all over 1 equals negative 1 over 2x plus 1 times 2x plus 1 times x minus 3 all over 1. Now we can cancel 2x plus 1 and x minus 3, which leaves us with x squared minus 23 times 1 plus x squared minus 3 cancels, leaving us with 2 times 2x plus 1 equals 2x plus 1's cancel, which leaves us with negative 1 times x minus 3. Distributing x squared times 1 is x squared, minus 23 times 1 is minus 23, plus, distributing again, 2 times 2x is 4x, plus 2 times 1 is 2, equals, distributing again, negative 1 times x is negative x, negative 1 times minus 3 is a positive 3. Now we want to add like terms. X squared plus 4x minus 21 equals negative x plus 3. We want to move everything over to the left side. X squared. Then I add x to both sides. 4x plus x is a positive 5x. Then I subtract 3 from both sides, and negative 21 minus 3 is a negative 24, and that equals 0. Now I can factor. I need two numbers that multiply to be a negative 24 but add to be 5. X plus 8 times x minus 3, and that equals 0. Now I can solve for x. X plus 8 equals 0, which means x equals negative 8, or I have x minus 3 equals 0, which means x equals 3. So we want to check this with our extraneous solutions. One of our extraneous solutions is 3. So x equals 3 is not part of my solution set, but x equals negative 8 is. Solving rational equations. 1. Factor the denominator or denominators if possible. 2. Identify any excluded values. 3. Find the LCD of all the fractions. 4. Multiply both sides of the equation by the LCD. 5. Solve the simpler equation. 6. Discard any proposed solutions that are excluded values.